Hello friends, let us now discuss about shapes of some more molecules. First of all, ammonia. In case of ammonia, the central atom is nitrogen, and we know that H is equal to half into V plus X minus C plus A. Now V is the number of valence electron of central atom. Here central atom is nitrogen and its valence electron is 5. X is monovalent atom. The number of monovalent atom is 3 and cationic and anionic charge is 0. So H is equal to 4. And L is equal to, L means lone pair electron, is equal to H minus X minus D. Now H is 4, X is 3 and D is 0. So lone pair electron is 1. Now the hybridization, H is 4, so hybridization is sp3, and when 4 orbitals are there, to minimize the repulsion between electron pair, they are directed along the 4 corners of tetrahedral. One corner is occupied by lone pair electron, and the other 4 pairs are occupied by 3 hydrogen atoms. They are directed along the 4 corners of an tetrahedral, but one position of the tetrahedral is vacant. So the shape of the molecule is not tetrahedral, but it is pyramidal, and expected bond angle is 109 degree 28 minutes because 4 orbitals are directed along the 4 corners of a tetrahedral, but the repulsion between lone pair and bond pair is greater than bond pair repulsion. The repulsion between lone pair and bond pair, that is LP-BP repulsion, is greater than BP-BP repulsion. That means lone pair bond pair repulsion is greater than bond pair repulsion, and the bond angle is slightly less than 109 degree 28 minutes. It is almost about 107 degree. So this is the shape of ammonia molecule. Let us consider another molecule, that is water. Here the central atom is oxygen, and the state of hybridization is half into V plus X. V is 6, X is 2, cationic charge and anionic charge is 0. So the value of H is 4, that means the hybridization is sp3. Now lone pair electron L is equal to H minus X minus D, that is 4 minus 2 minus 0, that means 2 lone pair electrons are there. Since there are 4 sp3 hybridized orbitals, they are directed along the 4 corners of a tetrahedral, 2 of which is occupied by lone pair electron, and the shape of the molecule is bent or angular, because the fourth position of tetrahedral is not occupied by atom, two of which is occupied by lone pair electron, and the shape of the molecule is bent. The molecule is bent or angular, or it is V-shaped, and due to presence of two lone pair electrons, the repulsion between lone pair bond pair is much greater, and the bond angle deviates more, and it becomes around 104.5 degrees, which is less than the predicted bond angle 109 degree 28 minutes. Let us consider another ion, say NH4 plus. Here H is equal to half into V. V is 5 because 5 electrons are present in the valence shell of nitrogen, and monovalent atom is 4. Monovalent atom is 4, and charge of cation is 1, charge of anion is 0, so its value is half into 5 plus 4 minus 1, that is 4, and that means the state of hybridization is sp3, and number of lone pair electron is L equal to H minus X minus D. So it is 4 minus 4 because divalent atom is absent, 0. So the shape of the molecule is tetrahedral, and 4 positions of which are occupied by 4 hydrogen, one of which is positively charged. Shape is tetrahedral. That's all about shapes of molecules and ions. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.